Okay, this is John Marsh, and in this short video I'm going to show you how to do problem 1 from homework 2 this semester in NCS 450-541. And this is basic networking review. So as a network administrator, you've chosen to use private IP addressing for a campus LAN. You have a need for 3 subnets with up to 50 users each. You decide to use a Class C private addressing 192.168.10.0. Okay. Suppose you use the first 3/26 subnets. Will this work? Explain your answer. Write down the subnet mask from A using dotted decimal notation. Write down the subnet ID, first IP address, last IP address, and broadcast address for each of these 3 subnets. And now finally in part D, you want the first subnet to be able to grow to 100. And I say here it is possible using this same Class C subnetwork with variable length subnet masks. And it basically asks you to show how that's done. So what I'll do is I'll start with the fact, so this is homework 2, problem number 1. Okay, and so we're going to take a Class C and we're going to use /26 subnets. Okay, and so the first question is, how many of these subnets are there? How many IP addresses per subnet are there? So suppose we use the first 3/26 subnets. Will this work? So the first 3/26 subnets. Let's figure this out. Every time I see a slash, I know that I'm going to go 32 minus that slash number, and in this case I get 6, and I'm going to say 2 to the 6th then is 64, and this is the number of IP addresses, IPs, per subnet. Okay, and because we started with a Class C leaves us 256 addresses to work with. Remember, a Class C means that we have a network number of bits is 24. The number of bits in the network part of the IP address is 24, and S plus H, subnet bits plus host bits, is therefore 32 minus n, or 8. And we have 2 to the 8th, or 256 IP addresses to work with in this Class C network. And if we have 64 per subnet, then we have 4 of these subnets. And you can write 2 to the 8 minus 6, or 2, which is 4 subnets. Okay, so this is what a /26 looks like, and if you go back to the earlier video, you can look at taking this Class C network, starting with 256, a /25 gives us 128, and a /26 gives us 4 blocks of 64. Okay, so this is where we start. And let's see, the number of host addresses per subnet is 2 to the H minus 2. And so let's see, 6 is equal to, this is equal to H, and 8 minus H is equal to 2, which is equal to S. Okay, S plus H equals 8. Okay, so 2 to the H minus 2 is 2 to the 6th minus 2, or 64 minus 2, or 62 hosts. Okay, so each of these subnets can hold 62 hosts. And the problem stated that we want it to hold 50 users each. And so 62 is greater than the 50 users, so yes, it works. Okay. Let's see, what did part B ask? B asked for the subnet mask from part A using dotted decimal notation. The subnet mask from part A using dotted decimal notation. Ah, okay. The subnet mask has ones, has 26 ones in it. Okay, it's going to have 26 ones, and then 32 minus 26, or 6 zeros. Okay, and 26 ones is really 8 plus 8 plus 8 plus 2 ones, and then 6 zeros. In other words, the first 3 octets are filled with ones, and we know that 8 ones in a row in a binary is a 255. And then here we have, in the last octet, we have 2 ones and 6 zeros. Okay, and this is a 1, 2, 4, 8, 16, 32, 64, and 128. So this, these 2 bits correspond to 128 plus 64, which is 192. Okay, and so, and each of these is a 255. And so my subnet mask is 255, 255, 255.192. Okay, so that's the answer for part B. And I will pick up with part C and D in the next short video.